Hello everyone, you're all welcome to another session of this course. And in this session, we're going to be modeling and building a box. The materials for this session are displayed already. We have our micro bits coupled with the ring bits. We have our actuator, and we have Legos. Let's run through the names of these Legos. What we have here are beams. So they come in different sizes. These ones here, the longest here, these ones are called 1 by 15 beams. And the reason being that, and why is that so? The one comes from the fact that it is just one straight column, and the 15 comes from the fact that there are 15 holes here. Let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1 by 15 beam here. Then this one here is called 1 by 13 beam. Let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then we also have 1 by 11 beam. Let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we also have, following that, 1 by 9 beam. Let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have 1 by 7 beam. Let's count: 1, 2, 3, 4, 5, 6, 7. And then we have 1 by 3 and 1 by 2 beams. We also have here 3 by 3 T-shaped beam. 3 by 3 T-shaped beam comes from the fact that there are 3 holes here and also 3 holes here. So 1, 2, 3, 1, 2, 3. 3 by 3 T-shaped beam. Then we have 2 by 4 angular beam. Let's count: 1, 2, 3, 4. Then 1, 2. So 2 by 4 angular beam, because it looks as though two beams are meeting at an angle here. We've got bushings. We've got bushings. We also have pin with pinholes. We have frames. We have an axle here, often referred to as axle 8. The reason being that when you put it side by side with a beam, the number of holes it covers is 8. Let's count: 1, 2, 3, 4, 5, 6, 7, 8. Then we have two angular beams here, though they're different. This is often referred to as 4 by 4 angular beam. Let's count: 1, 2, 3, 4, and then 1, 2, 3, 4. 4 by 4. And then we have 7 by 3 angular beam. Let's count: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 7 by 3 angular beam. So we have pins here and then 3L pins. So the basic difference between these pins and then these pins is that these black pins here can connect just two beams together, while these 3L pins can connect up to 3 beams together. Now, the next thing we are going to do is to begin to build the box. So the first step is build a frame, and then add 4 pins here: 1, 2, 3, 4. One here, 2, 3, and 4. Yeah. So the next step is to add two 1 by 7 beams. So this also, sorry, 1 by 7 beams here, and also here. So the next step is to add pins on this side also. So I'm going to be adding 4 more pins: 1, 2, 3, 4. 1, 2, 3, 4, like this. Then we're going to add two 1 by 9 beans here and also here. We are basically building the base of the box. We'll add two more pins here, 2, 2, 2, 2. 1, 2, 1, 2, 1, 2, finally 1, 2. Oh, the next one is to add this 4 by 2 by 4 beans here. So we'll add it like this. Here, easy. Here, here, and here. Then we're gonna add two pins here, 2, 2, 2, 2. Let's go. 1 here, 2. We'll add 2 here. We'll add 2 here. And we'll add 2 here. So that's it. The next thing we're going to be doing is to add 4 195, 415 games. The next one is to be doing the next one is to be to add 4 115 games on 1, 2, 3, 4. Let's go. 1 like this. 2, 3, 4. So from here, from this point here, let's add 4 holes up, then the fifth hole, let's add a pin. Then from here, let's add 3 holes, and then the fourth hole, we're going to add another pin. We're going to do it like that for all of them. Then here, and then so the next thing we're going to do now is to add 4 1 by 11 beams, 1, 2, 3, 4. Here to connect the pins. Let's go. And then we're going to add here. Good. The next now is to add two 3L pins here. 1, 2, 3, 4. Then we'll add 1 by 3. Two of them. 1, then another one. Then this T shaped and go right in. Right here. So add easy. So add another one here. Then I'm going to add two pins. 1, 2, and then 1, 2, 3. The picture is already forming. So it's forming now. Then we're going to add 1 by 15 beams too here on this. I guess 1, look, make sure you leave 1 hole here, then the 2. Same thing. So now the next one we'll do is to pick two 3L pins. One is going to be here, another one is going to be here. All right. Then we're going to add two pins. One is going to be here. The one is going to be here. 2, 1. Now the next we're going to pick are 2 1 by 2 beams. One is going to be here. Another one is going to be here. Then we're going to add 1 by 11 beam. Then we're going to add 1 by 11 beam here. Then we'll pick two pins with pinholes. This one here, another one here. Then we'll pick two of it more again. Now, one of them is going to be here. Another one is going to be here. So we're going to add two long pins, that's 3L pins. To add two of them. Make sure they like this. Turn this properly to the other side. Then you add this. Now the very next thing we are going to be doing is to add the two 1 by 13 beams. We are going to connect this to this using 1 by 13 beam. Using 1 by 13 beam. We have this here, another one here. Here also. The next one to do now is to release the cover of the box. Just pick my frame and then add one pin here, another one here, then two more here and here. I'm going to use 1 by 15 beams for them, one on this side, the other one on this side. Then take actual 8 and then make it also here. Then 7 by 3 comes like this. And close it. So we need to lock the actual side substance in. So use a division on this side and then division on the other side. Add this to the box. So bring the box and then one here. Then the next hole after the bushing. And then the other one here. So when you pull it down, it opens. Once you take it back up, it closes. So we need to add an actuator here. So you add two pins, one here first, and the other one is going to be here. Then I'm going to put the actuator here, like this. Turn it the other way, like this, and not like this. So it should not be like this. It should be like this. Then we'll get the 4 by 4 and then add this here. So add it here. Then we have to use this. We have to connect two of them together. So we'll be using an axle with a pin, one here, this hole here. The first hole after the axle hole. Like this. Yes. So the next thing I want to do now is to program the box. Alright, the next thing we want to do now is to program the box. So we are going to program the button controlled box first before we program the smart box. How does the button controlled box work? When we press button A on the microbit, the box opens. And when we press button B on the microbit, the box closes. That's how it operates. So for the smart box, we are going to be introducing sensor, and we already know what a sensor is. Part of the robot that helps the robot to interact with its environment. We are going to be introducing an ultrasonic sensor box, and then once the ultrasonic sensor detects an object, the box opens on its own and then waits for seconds. Closes. So let's start with the button control. So I'm on my browser already, and I'm just make code microwave.org. I'm in already. Gonna come to new project and name it box. Yeah. Now for the box to open, an actuator has to help the box with that. So we need an extension to control the movement of the actuator. We'll come to extension, then come to the search bar and enter ring bit bar. And we have it here. Good. We want when we press button A, the box opens, and when we press button B, the box closes. So we can take out this one start, and then we come to input and drag out A pressed. We want then we come to ring bit car and drag out spin right 0 degree. We change the 0 there to so when it spins right, the box opens. So once when we press button B, the box should close. So what block do you think we should bring out? Yeah, is the spin still the same spin right block? For now, we change the right because we want to come to input and drag out on button A press again. Change the A to B, then we'll come to ring it and drag out in right so it goes. Change the right to left, same angle, 5 degrees. So that's it. When we press button A, box opens, the actuator spins right after 5 degrees, opens it. And when we press button B, the actuator spins left upward 5 degrees, closing the box. So now that we're done programming the box, let's test it. So we connect the mic actuator to any of the pins on the ring bit. We do not assign any pin. So when I press button A, opens. When I press it again, it opens even further. When I press B, closes. Press B again, it closes. Let's try one more time. A opens. B closes. We will need an extension to help us control the ultrasonic sensor. That extension is called Sonabit. Unfortunately, it's called Sonabit. We come to extensions and instead of us typing Sonabit here, it's not going to show. Is a link. So here is the extension here. So this is the link. You can as well take note of it. So we click on this Sonabit. Now we're going to be introducing some logic here. If and then before that, let's come to basic and then we'll drag out the forever block. Now we want if the ultrasonic sensor detects an object that is between 1 centimeter and 5 centimeters away from it. The box. So we'll come to logic here. So before then, we need to create a variable to store the block, to store the value returned by this block. We'll come to the variable and then we'll click on make a variable. So we name it and okay. So now we need to store a value into this variable because a variable is basically a container that a con- because a variable is basically a container where you store data for future purposes. So we drag out the set sona to 0. So with this block, we're trying to store data. We're trying to store a value into the container name tag. So we'll come to Sona bits and then we'll drag out this block. So this block basically returns the distance between the ultrasonic sensor and the closest object to it. and the closest object. So let's change the unit from. So let's change this pin to P1. Now we've assigned the value. We've successfully stored the value that this block returns. So we've successfully assigned the value that this block returns to the sonar variable. So now we're going to be making use of conditional. We'll come to logic here and drag out if true, then here. Conditional statements basically works like this. For something to happen, a condition has to be met. So for you to, let's take an example there. For you to use your umbrella, then it has to be raining. Or for you to use your cardigan, then it has to be cold. So if it's not cold, there's no point using it. So for you to be able to use your cardigan, that condition in cold has to be. So now we're going to create a range of distances that an object has to be within for the ultrasonic detective. So we'll come to logic again, come to boolean first, drag out this and this is here. Then we'll come to logic again, then we'll drag out this block from comparison, drag it twice. Instead of going out to drag it again, you can always duplicate. So how do you duplicate? You right click on the block and you click on duplicate. So that's how it works. So another one here. So you come to variables and drag out this sonar and we'll place one here. So it duplicates that here. So if sonar is lesser than or equal to 5, that means if the value that this block returns, if the value that this block returns is from 5 centimeters downwards, and if the value that this block returns also is greater than or equal to 1. So if the value this block returns is from 5 downwards, and the value it returns also is from 1 upwards. So if it is from 1 centimeter to 5 centimeters, so if it is from 1 centimeter to 5 centimeters, then what will happen? We want the box to open. We are going to be using a block that helps the actuator to. So we are going to be using this block go forward for 0 seconds. This block is mostly used with cars, but it can also be used for lines. So go forward for let's say 3 seconds. So the actuator spins in the same manner as driving a car forward. So it, it does that for 1 second. It does that for 1 second. And after doing that for 1 second, it breaks. We come to ring bit car, I will drag out brake, we place it here. Then how long does it stay? Just for another 2 seconds. We come to basic, scroll down and then drag out pause, place it here, change this 100 to 2 seconds. So you notice that this changes to 2000. That is because this time here is measured in milliseconds, not just in seconds. So 1,000 milliseconds make a second. 2,000 milliseconds is going to make 2 seconds. So after staying for 2 seconds, they're staying open for 2 seconds because they go forward for 1 second, it's going to open the box. After staying open for 2 seconds, it needs to close. So it comes to ring bit carry, and they will drag out, go forward for 0 seconds again. They will change this to backward. Then yeah, so that's the code. First we did we needed to get a forever block so that this whole instruction will keep running in a loop. So it doesn't have to you don't need anything to start it, you don't need anything. Just microwave scripts non-stop. So every time an object comes close to the ultrasonic sensor in the range of 1 centimeter to 5 centimeters, then the box opens, stays open for 2 seconds. The box opens for 1 second, stays open for 2 seconds before closing back. Now the next thing we want to do is test. So now that we're done programming the smart box, let's so when I test come it. Close to the ultrasonic sensor, it opens and then it also closes. All right, thank you for staying through. I'll see you in the next session. Bye.